Welcome to this e-learning module from Synapsys Solutions Limited. This training module will focus on the SIP2 multi-protocol. This module will go through the initial setup of the SIP2, how to configure the drivers available, and outputting the data in various ways. The SIP2 has various ports with corresponding LEDs for use with the multi-protocols. One Ethernet port available for connection and comms to a configuration PC and for communicating with protocols via TCP/IP. One RS485 port and one RS232 port to be used for connecting the Modbus master driver to Modbus slaves. A dedicated MBus port is available with a built-in MBus level converter, allowing up to 60 unit loads on an MBus network. A digital input port that can be used as a digital input or pulse counter to bring in a single pulse signal. A 24-volt DC power supply is required to power the SIP2. The diagram shows the different network connections available. The SIP2 uses a single Ethernet port for connection to a configuration PC and for comms across a TCP/IP protocol. To begin configuration, connect a PC to a SIP2 using a Cat5 cable from the PC Ethernet port to the SIP2 Ethernet port. Ensure the PC's IP address is set within the range available. It would need to begin 192.168.1. The subnet mask specifies the range of IP addresses that can communicate with the device. Synapsys Solutions do supply specialist software via SIP integrator called SIP Search. This SIP software will search an IP network that is visible to a PC for any Synapsys Solutions products. Please contact Synapsys Solutions for more info on this. Once the SIP2 is connected, the web pages will be available. Use a web browser, Google Chrome, Firefox or Microsoft Edge, and enter the IP address of the SIP2 into the URL bar at the top of the screen. The default IP address can be found on the Quick Start guide that came with the product. This will display a login page. The default login username is admin with a capital A. The password is password, all lowercase. The IP address will need to be set in accordance with the network the device is connected to. This is done in the IP config page. The global settings page allows a user to set a site name, a SIP name, and set the time settings as required by the site. There is also a reboot and a ping function available. To start acquiring data via the SIP2, the desired drivers will need to be created and set up. This is done in the Manage Drivers page. All available drivers can be seen on the slide. The SIP2 will only allow a single instance of each driver type, with a maximum of 4 drivers, plus the digital input. The ports drop-down box is used to change the variation of protocol. For example, to use Modbus TCP/IP, select the Modbus driver and select the Ethernet port option. The managed drivers also allow an alias to be entered for each driver. This makes it easier to organize which driver is which when using more than one of the same protocol. The cog to the far right side of each driver contains the communication settings for that driver. Each will be dependent on the driver and port selected. I will go through each of the COM settings pages as I go through the drivers. The COM settings for the Modbus driver vary depending on the port defined. The baud rate, parity, data bits and stop bits are only relevant to serial connections of Modbus over RS485 or RS232. These settings are used to define specifics related to the data as it travels along the serial connection cable. The timeout defines how long the SIP2 will wait after sending a message and not receiving a response before sending another message. The polling period defines how often the SIP2 should attempt to communicate with the Modbus slaves to get data. The two protocol options for Modbus are Standard Modbus or JBus. There is very little difference between these two options. The only noticeable difference is that JBus uses registers that start at 0, whereas Modbus registers start at 1. This means that register 1 using Modbus would be the same as register 0 using JBus. 0 values on comms failure defines what happens to data when a SIP2 fails to get a response from a slave. When a slave is no longer available, when this is off, The SIP will hold the last known reading. When it is on, it will set all values from this slave to 0. The communication failure threshold defines the number of messages the SIP2 failed to get a response from before defining a certain slave as a failed device.
Once the COM settings have been set up for the meters attached, the slaves and points need to be configured. This is done in the Define Points page. After creating a Modbus driver, this will appear as a new option in the menu. To create a new slave, press the Add button and enter the slave address. When using TCP/IP connection, an IP address is also needed. For each slave, the points that are required from the meter are entered into the table. To create points, add rows to the table using the orange arrow button. The register number is an ID number for the specific parameter that is required. The quantity allows multiple consecutive registers to be configured and polled at once. The data type needs to be defined correctly as per the meter manufacturer guidelines. The function code can be defined as coil, input, holding register, or input register. Function codes 1 and 2 are for binary or digital values of 0 or 1. Functions 3 and 4 are whole number values. The next two slides can be used for reference when determining which data type is required. The following slides will go into more detail on the 4 function codes and what these mean.
The scaling factor allows a multiplication to be made to the value after the SIP2 has received it. In Modbus, only whole numbers can be sent, so if a decimal value is required, it would need to be scaled. For example, the value for a temperature sent from a meter might be 215, but the actual temperature value would be 21.5. This would require a scaling factor of 0.1. The offset allows the value to be altered by adding or subtracting from it. This is most commonly used for pulse counters. When a pulse counter has counted a certain number of pulses before it has been fully commissioned, these can be offset by using a negative number. There are also cases where a positive offset may be required. Dynamic scaling can be used when it is required that a value read by the SIP2 will need to be scaled by a second value in another register in the meter. The bit mask allows specific bits from a digital 16-bit register to be defined independently. The comms traffic and the custom comms tools are used for diagnostics. The comms traffic page shows all messages in and out of the SIP Modbus driver. Green shows incoming messages, yellow shows outgoing. When performing correctly, these should be alternating as a message and response sequence happens. When all messages are yellow, it means the SIP is sending messages but is getting no response. And when there are red messages, it means there is an error which will be defined by an error code. The last 100 comms packets show the messages sent and received in original hexadecimal format. The last 100 feedback messages show in plain English what is happening and what errors are being flagged, if there are any. The custom comms page allows more specific diagnostics to be done. The read section will allow for individual registers to be read, retrieving data. To find a value, enter the details of the slave, the register, and the factor and offset. The bottom of the page will display both the request packet sent by the SIP2 and the response packet received from the Modbus slave. Modbus errors will also be displayed if there is a problem with the configuration. A list of error codes and what they mean can be seen on the next 2 slides. MBus can only communicate over the designated port. A key aspect of MBus is the requirement for a level converter after the MBus master. The MBus port has a built-in level converter with up to 60 unit loads. In the COM settings options, various settings need to be configured as per the meter manufacturer documentation. Polling interval can be set to poll the meter as often as is required. The comms failure settings describe the requirements for when an MBus meter goes offline. Max telegrams and ignore checksum can be used for specific scenarios and refers to the telegram messages being sent from the M-bus meter to the SIP2. Secondary addressing allows for two different ways of addressing M-bus meters on a network. Primary address generally requires manually configuring meters to set an address number between 1 and 250. Secondary addressing automatically defines the address as an 8-digit number. This will generally be the serial number of the meter, meaning all addresses will be unique. The Discover Meters button allows the SIP2 to search its visible network for all secondary addresses or a range of primary addresses. Open the Discover Meters tool and enter a primary address range between 1 and 250, or select the secondary addressing tick box to select the full range of serial numbers.
When the search is completed, all available meters will display on the right side of the pop-up. Use the Read button to learn the points available in the meter. Once all the points are shown, they can be added to the list of points being polled by pressing the Add button. Points can also be added to the table manually by adding a slave address at the top of the page and adding rows with point IDs into the table. There is also a duplicate function if multiple meters of the same type are used in the same network.
MQTT is an IoT protocol. This is a lightweight protocol communicating using an Ethernet connection over TCP/IP. This can be used with a local MQTT broker or an IoT edge device, or a cloud-based broker. Use the COM settings within the Manage Drivers page to configure the connection settings to the desired broker. More information about brokers can be found online or through Synapsys solutions. However, this is not a feature we supply currently. MQTT requires a broker as a central hub for communications. This works as a server device, accepting connections from and passing data between clients, like the SIP2. The SIP2 can act as both a publisher or a subscriber device in the diagram provided, meaning it could send data to a broker or it could receive data back. Examples of MQTT brokers are Amazon Web Services, Google IoT Cloud, and Microsoft Azure. After setting up a connection to an MQTT broker, the points can be defined in the Define Points page. The address points in MQTT are named topics. This is what is used by the broker to decide where the data is coming from and going to. Clients subscribe to a topic to receive data on a change of value basis. The COV setting allows how much a value must change to send or receive an updated value. The property settings change the way the data will be sent or can be read. The SIP2 either uses plain text numerical values or JSON formatted data with a timestamp. The access option defines whether the point is read-only, which means the data is being sent from the broker to the SIP2, write-only, where the data is coming from another protocol and being sent to the broker, or bidirectional. The SIP2 includes a single digital input port that can be used to bring in a digital input or count pulses. The driver communicates through the designated DI port on the SIP2. Create the driver in the Manage Drivers page and select the COM settings button to the right. The two mode options available are digital input or pulse counter. The digital input will define either a 1 or a 0 as a status depending on the signal being on or off. The pulse counter will accumulate the pulses coming in with various parameters available to output. The pulse weight can be set, allowing the number of pulses to be multiplied depending on the pulse meter manufacturer. There is no Define Points page for the digital input driver. The available points can be found in the Link Points page, depending on the driver mode selected in the COM settings. The digital input mode will display the status point. The pulse counter will allow pulses, pulse weight, value, and units to be available points. The SIP2 provides the ability to interface data from one protocol to another. Once data has been brought into the SIP2, it can be made available to a trend or backnet BMS or out over an IoT protocol. To configure protocols to export data, create one of the server drivers in the Manage Drivers page. This could be VIC to communicate over trend, backnet over IP, MQTT, or REST server. To interface to a trend network, create a VIC driver. The VIC driver allows up to 100 outstations to be created as unique trend devices on the network. Use the COM settings to define the node and port information of the two onboard VCNCs, the UDP group and the LAN number. The human GUID can be entered here as per the site requirements. When configuring the VIC driver, ensure the UDP group is set the same as the devices that the SIP+ will be communicating with. All LAN addresses on that UDP group must be unique. Use the VIC define points page to create up to 100 outstations, using the column down the left side of the page. Add a unique outstation number between 1 and 119, ensuring that 2, 3 and 10 are not used, and press the Add button. The new outstation will appear and can be configured. Open the outstation and add a label, alarm, specifications and attributes that may be required. The next 4 headings will enable individual configuration of sensors, knobs, inputs and switches. The final option defines the users for the outstation, allowing trend security to be added. When configuring the required modules, ensure labels, units, high and low limits and plot information is entered where they are needed. The copy and paste function allows this information to be copied out in a CSV format and edited in an Excel document. The table can then be pasted back into any other created outstation. You can also right-click an outstation to duplicate it. To interface data to a BACnet BMS, the BACnet driver over IP needs to be configured. BACnet uses a structure as displayed on the slide. All devices will need to be on the same BACnet port to communicate. Most devices will sit on network number 0, the local network. Any device behind a BACnet router of some kind will sit on a unique network number, including the SIP2. All BACnet devices and objects must be identified by an instance number, which will be unique through each level of the hierarchy. The properties of the BACnet object include a present value. This is the property we use to poll data.
Open the Define Points page to configure the BACnet servers. Server devices need to be added. Use the Add button at the top of the page to add a new server device, giving it a unique instance number and label. The description and location are additional extras. To create data points in the BACnet server, use the table on the left of the page and press the orange arrow to create points. Each point will have a unique instance number, object type and label. For each object type, different configuration settings will show in the main body of the page. These settings are used to configure the properties of the individual points. For more information about the configuration of these settings, refer to the SIP2 technical guide or contact Synapsys Solutions. To interface over IoT, there are 2 options, MQTT or REST. When using MQTT, configure the driver as described previously in the module. Ensure when points are created, they are set to either write-only or read-write to send data to the MQTT broker. Interfacing between 2 protocols requires the points to be linked together. This is done in the Link Points page. Select the 2 drivers to be linked from the drop-down boxes at the top of the page. Select the points required on both sides and press the Link button. These points will be linked in the order that they are selected. Make sure the links are saved using the button in the bottom right of the page. To select multiple points at once, Shift button can be used. Hold Shift and select 2 points to select all in that range. Another shortcut will allow all points to be linked in one go. Ensure no points are selected and press the Link button to link all points in the order they are currently in. As well as interfacing between protocols, the SIP2 can send reports as CSV formatted files via email, FTP or FTPS. This is configured in the SIP data tool, which can be acquired from SIP Integrator or Synapsys Solutions. Use the tool to log into the SIP2 and create a data reporting driver. This will enable the access to the data reporting tab in the menu. Open the data points page to begin configuring the points to be reported. Add new points using the button at the bottom of the page to find the number of points required and enter a label prefix where necessary. The label prefix will add the same starting label to the beginning of each point. Label each of the points with a unique name. The copy and paste buttons can be used to copy points labels out in a CSV format and paste them into an Excel document. These can then be edited and pasted back into the SIP2. Once the points have been configured, they need to be linked to the correct input points. This is done in the Link Points page in the tool. This is done in the same way as interfacing as discussed previously. The recipients of CSV reports are defined in the Recipients section from the menu in the tool. Add a new recipient to the box on the left of the page. Label the recipient and add the details for the destination of the report. This can be an email address or FTP details. Select the report type at the bottom of the page and set the time for when the report will be sent. Finally, select all the required points for this report in the box on the right of the page.